Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve this piston in static analysis. So here we are in the top surface, we are applying the pressure of 18 megapascal, and here these two surfaces we are fixing it. Now we'll solve this problem using salome. And important is, please subscribe my channel and click the bell button for continuous notification. Now we'll solve this problem using salome. Now I have opened salome. First you just go to geometry model. In this piston model I have already created and saved as a step file. Now I'm going to directly import this file using import option. So here you can see I have saved this engine piston as a step file. Now I'm going to open it. Just go to file, import, step file. So just navigate the folder, piston, just open it. So any geometry you are opening into or importing into the geometry model of salome, first check the dimension. Go to inspection, dimension, bounding box. So now this is in the meter unit and the dimensions are correct. If it is in the any change in the dimension or any scaling is happened, you have to modify the dimension. So we have to scale it. Now we have imported the model. Then we will create the groups to apply the boundary conditions. Just go to the PPT. We have two groups or two boundary conditions. One is pressure, we have to apply it here, and other one is here we have to fix it. So select this engine piston, new entity, groups, create groups. One is face group, select this top face, add. Here I have to apply the pressure, just apply it, and here this surface as well as this surface. Press the shift and hold it and select this surface, then you just apply it. No, before we have to add it. Here you just name it as fix x, y, z, then apply and close. Now you can see this one. Here we have to apply the pressure, here we have to fix it. Now we'll save this file. Now I have saved it. Now we'll move into the meshing model to create the mesh. Select this engine piston, mesh, create mesh. Here I am going to use the same NetGen algorithm. So now in this tutorial we are going to use GMesh algorithm also we can use. Just choose GMesh. Here also we can go for tetra element. There are different algorithms, 3D algorithms are there. Automatic, mist adapt, Delaunay, frontal algorithm, Delaunay for quads, packing up parallelograms. There are different algorithms are there. Here I am going to use automatic, this same Delaunay method, simple. Element size factor I am just keeping 1. So minimum size is 0.001, maximum size is 1. Just say OK, then apply and close. Right click this mesh one and compute it. Here you can see we have created very coarse mesh. Now just edit this mesh, go to the parameter 0.0001, this one just 0.001 I'm just giving, 0.005 we can give, Say OK and apply and close. Right click, clear and compute. I think we have created very fine mesh we have given, it seems. Just cancel it. Here you can see we have given very fine mesh parameter. Just close it, edit the mesh. Here just make it 0.01. Just say OK, apply and close, right click and clear and compute. Now also it is generated with the coarse mesh, edit mesh 0.02. Say OK, apply and close, then clear and compute. Yes, now we have created tetra element with the triangular patterns. Everywhere you can see only the triangular, you can see equilateral triangle it is trying to make, and it generated the tetra element. This is one kind of generating the mesh. Just go to edit mesh. This mesh is enough for me. Now we'll take this mesh for solving. Now just move into the aster study to create the setup. Just say OK. Now I am going to use here same wizard or assistant, isotropic linear elasticity. Next. Young's modulus Poisson ratio we have to modify it. So Young's modulus is 71. Here it is showing megapascal, that means 71 gigapascal. 71 e power 9. Poisson ratio is 0.33. These two material properties enough to solve the linear static analysis. Next. Then impose the degree of freedom on the groups. That means fixed group boundary conditions. So this has to be fixed in all directions. Then go to next. Then pressure on the meshes groups. So we have one pressure with the value of 18 megapascal. That means 18 e power 6. Just next. Then we'll save this file. So I'm just naming as result.rmed. Just save, then finish it. Now you can see it here. So now we have created complete setup. So nothing need not to modify. Only thing is the solver, it will only generate displacement. To see the stress values, go to post processing, call champ, use the same previous value. Here directional stress sigma L0 and sigma nodal. Here equivalent L0 and equivalent nodal. Then just apply and OK. Now I am calculating this one. Then the same has to be written as an output file. So change this value to result champ. Tau champ make it S. Just say OK. Then you just apply and OK. Now complete setup I have created. Now we can solve this file. Just go to history view, save this data, click this +1, auto refresh make it into 5, then just run it. The same piston we can create XMesh also, but it will take more time to generate the XMesh. So for that I have generated only TechMesh. Now it is solved without any error. Here you can see in command file also we can check it. There is no error and common warning only it is coming. Now we can go for paraview to do the post processing. Go to paraview. This paraview will not take the data directly. We have to open the output file, go to pictures, code aster, piston. So this is my output file. It's okay, then I'll apply it. So here you can see all the data are available here. Here we can one by one we can check result displacement. This one is the displacement. I'm just changing this displacement value into blue to red to view the proper color. And here also I'm just making into 12. So this one is the displacement profile. So maximum displacement we are getting 2 e power minus 4. Minimum is 0. So here we are fixing it, that's why we are getting minimum displacement. So here we in different surface with edge also we can check. So surface with mesh values. So then we go for surface. So this one is the displacement magnitude. We can check the displacement in x direction, y direction, z direction. This one is the y. We can animate the displacement in using animation also. Further just go to wrap by vector, give some scaling, then apply it. So this is the way while applying the pressure, this is the way deformation will happen. We can animate it. Instead of 92 scale factor, I'm just giving 30. Frame I'm just giving 20. Just say OK. Now we can animate it. We can loop it also. So this is the way animation we can see it. Now we can check the stress values. First we will check the von Mises stress. So this also we can change this color into blue to red rainbow. And here I'm just making it 12. This one is the magnitude actually. First we'll see the von Mises stress. So here we are getting very high stress, that is because of we are constraining, we are applying the fixed boundary conditions. So for example, maximum stress we are getting 290 megapascal. For example, we just want to see the stress ranges between 200 megapascal to 290 means, that is we can set it custom range. Here I'm just giving 250 e power 6 to this value. Just rescale the data. So only we are getting a maximum stresses here, that is because of fixed boundary conditions. So remaining area are, so stresses are less than 250 megapascal, that means in safe zone. This way also we can check. To reset the scale data, use this option and just click it. So it will reset the data. Similarly, we can see the stress curve stress, principal stress 1, principal stress 2, principal stress 3. So similarly von Mises. So this way we can check the results in post processing. For example, we want to check the results in here. That is also we can just select this hover point and check the data with this hover point also. So here the data, the stress is von Mises stress is 128 megapascal and sigma xs is minus 126 megapascal. Like that way also we can check it. So in this tutorial we have learned how to solve mechanical or static structural analysis of piston. In next tutorial we can see with another component. Please subscribe my channel for more videos and click the bell button for notification. Thank you.